Okay, continuing the lecture on landscape and site design, this section will mainly talk about topography and vegetation. But first I'd like to just finish up a bit on water and point out the importance of thinking how you think about wetlands in a design process. In the past, wetlands were not really well understood or no one cared about them. They were seen as this kind of wasteland, and the whole history of urban development and regional development in the U.S., you can see is a lot of it involving the filling of what was seen as wasteland and turning it into productive farmland and developable areas. And in the past 40 or 50 years, we've come to understand the importance of these areas and why we shouldn't do that. They're really important in terms of managing the local environment, in terms of the ecology, of providing for different species habitat, of managing rainwater flows in an area, allowing them to recharge into the aquifer, or slowing down the flow of water over the land so it just doesn't dump into rivers and into drainage systems, of providing protection from storm surges. There's just so many things they do for us that starting back in the 1970s, we got much more serious about protecting these lands. And if you've been out to the Eugene wetlands on the west end of the city, you can really sort of see how extensive they are and how they really process a lot of the water moving into the Amazon Creek and the Long Tom River and eventually into the Willamette River. So the main thing to understand as a designer is if you have wetlands on your property, it's likely you just can't touch them, right? There's a setback. They'll be delineated as to what areas are wetlands and unbuildable. There will often be differences amongst different maps. The Army Corps of Engineers might map it differently from the local environmental offices and such. So be very clear about what the designated and protected wetlands are on your property. In places like Eugene, where we have an extensive wetland system, there might be some possibilities for building on them. For example, if you have a small site and you have a small amount of wetlands on it that really are contributing in a very important way to the overall health of the system, Eugene has a program whereby you could, say, build on those wetlands, wipe them out on your property, and pay into a fund that would rebuild or reconstruct an equivalent amount of wetlands in a larger system such as out here in the West. So just be aware that normally you can't build on these, but if you're going to, there are other considerations to plug into. The most extensive, wetlands I've seen, and some of the most important in the country, are those in southern Louisiana and the whole system of bayous at the mouth of the Mississippi and other rivers. This is what the top picture is kind of what a generalized bayou environment looks like, and the bottom is on the road out to Fourchon and down to Grand Isle. It's an area of receding wetlands. This is an area really impacted by the oil industry. There's about 600 offshore oil rigs here, and there's a large port called Fourchon which serves those oil rigs. And to get there now, it used to be a dirt road through the land, and now there's an extensive, huge causeway to get through this because the land is disappearing at a rapid rate. I've heard that Louisiana is disappearing at the rate of 3 acres per hour, both from land subsidence, because the levees channelize the river and keep silt from replenishing the land when the river overflows, and also because of storm surges that come up into the wetlands, into the bayous, simply because there's been so many channels cut through it for navigation and other uses that it allows this intrusion of storms. So Katrina was sort of the best example we have of why you need to think about these systems. If there had been a really intact wetland system between New Orleans and the Gulf at that point, the damage would have been much less. It would have really protected the city from that storm surge. Okay, but now we're going to come to topography, and we've been talking about water, but one of the main reasons we care about topography as designers is the impact it has on water. You know that the basic rule of thumb is that water flows perpendicular to a contour line, right? It's sort of the fall line if you're a skier. And so when you look at a contour map, you should be able to understand where the water is going to go. And one of the prime designers as an architect, reasons to think about this as an architect is to make sure the water is going away from your building and not all dumping onto your building from uphill. This is a really nice little hypothetical plan here that you should take a closer look at in the slideshow of the lecture, just so you understand it. It's got every kind of topographical condition noted, and so you can see what the contours will look like, so you can understand where there's a valley, where there's a ridge, where there's a high point, where there's a steep slope where the contours are close together, where there's a shallow slope where the contours are very far apart. So take a look at that and try to understand what's going on there. That's a really abstract way of looking at a site, right? When you go out to a site, and we talked about how people like James Cutler go out and spend a lot of time on a site to become aware of its qualities and how that should influence the design. A site is a very hard to understand the data. I find that people, when you go to a site, we always really underestimate the amount of slope on a site. We may think of a site as being relatively flat, and then you actually measure it and you realize it's dropping about 6 or 8 feet across the site. This is a pretty common thing about our perceptions. So here's a site. I'll just use this one as an example because I have a lot of drawings of it. A site on Whidbey Island where we built a house, and this is the site in its original state. Completely covered with brush and trees, and the brush was about 12 feet high and completely impenetrable. The surveyor managed to find one path through the site that he could go down to shoot some topographic stuff there. And this is what we got from the surveyor. Okay, that's the abstraction of the site. Surveys used to come on paper. Now you basically get a few layers in DXF format or something, and you can plug them right into your CAD files, which is really useful. It's kind of hard to understand, so I'll just walk you through what all these different elements are. First is the property line. Which is outlining 80 by 100 foot site, and these are all located very accurately by the surveyor out there. The second is that's the edge of the street, and you didn't do it too carefully since it's about 25 feet from our property. And this just shows, as I mentioned, how a right-of-way is often about 60 or 65 feet wide, and the paved street here is only about 22 feet wide. So there's a large expanse of vegetated area between the edge of the pavement and the property line. That's public space, but generally maintained by and considered usable, by the people who own the property. The next thing is these are the two adjoining existing houses. They're mapped pretty closely so we can understand things like setbacks and shadows and views, etc. This was the line of the brush. The site was overgrown, and the brush didn't just stay on the property, it extended into the public right-of-way. So the surveyor mapped the edge of that brush line so we could understand it. And then an important thing was an incursion on the site. The neighbors had built a fence that went onto our property. So that was important to know. The residents there who were renters probably didn't even know where the property line was, so they just started using it, and so that was marked so we could have a conversation with the owner and say, that's our property, and we're gonna take your fence down and straighten those kind of things out. And then the most important thing here, there's trees. Okay, there's a bunch of trees you can see marked: an 18-inch fir, 16-inch fir, 6-inch madrona. The surveyor just puts down where the trunks are located and tells you how big they are, but always keep in mind that trees are much bigger. Their canopy and their drip line is way beyond that. And so here's kind of really the areas of the site where there was significant trees that we maintained as we built. And a few other things right off the property there. There's a power pole, a telephone pole with power lines and cable and all sorts of stuff that we had to, not on our property, we couldn't impact it, but we had to really design around it. You don't want to put your driveway right there. And then finally, the topography. These are the spot grades. A surveyor does not go out there and try to draw contours while on site. Surveyors take what are called spot grades. They shoot the elevation at specific points, which they map carefully, and then they can later go back and construct the existing topographic lines and contour lines from that data. And we'll get back to that in a little while about how to do that. This is a finished site plan, which just shows all of that information, some existing information, but then also the changes. So the house footprint has been put on, the setbacks have been marked on it, an easement from the neighbor's property is marked. The proposed new utilities, water line coming in and a sewer line going out, have been marked on there. Potential driveway has been mapped out. So all the information about what's going on that site. The dark lines, it's sort of angular dark lines around the house you can see. Those are actually the proposed contour lines. And you'll notice that what they do is they either connect to an existing contour line or they sort of die into the house and kind of come out the other side. And that's the way contour lines work. When you're thinking about going back to that hypothetical plan, this is just a nice little illustration. So here's the corresponding, here's a topo 6 example topo plans, but with the section cut through them showing what the land is doing. And if you're working, and sometimes if you're not as familiar with contour plans, you can just get confused as to what's going on. So the simplest thing to do is just cut a section right through there. And you'll see that number 5, the ridge, and number 4, the valley, the contour plans look kind of clear. And they're very similar. And so the only way to know whether it's a ridge or a valley is to look for the labels on the different contour lines, and that'll tell you whether it's sloping up or down. So just, again, familiarize yourself with these things. What architects and designers and engineers do is we often modify the topography. So this is, and what we do are called cut and fill. Cut is where you cut into the existing slope and remove earth, and fill is where you pile dirt up. And so those are the two fundamental things. And one of the goals, actually, a lot of the time in site design is to balance them. It's hard to get rid of dirt you want to get off your site, and it's even harder sometimes to find dirt if you want to build things up. So having a balanced cut and fill where you cut out dirt one place and move it to somewhere else is an important sort of economic efficiency strategy. And so you can see here that in this plan there's a desire to create a couple of flat areas, and in order to do that, so on the right it's a cut, and on the left it's a fill. So you create two flat areas, which might be a yard or a building platform or a path or something. And then if you look down below in the topo plans, you can sort of see how the existing dashed contour lines have these solid lines coming off them, which are the proposed lines. So just, again, familiarize yourself with these conventions. This is a big, complicated site plan. This is a site plan for a regional shopping mall, with a very big one with 4 department stores labeled A, B, C, D, and all the parking areas around it. And mostly what you're reading there are the proposed contour lines. And then to the bottom right corner of it, it's on a very steep slope, and it goes down to a retention basin for water at the bottom. Below the plan, you can see a couple of sections, the 2 sections cut across the site. And usually, when people draw engineering sections like this, they exaggerate the vertical scale. And so it's not exactly that amazingly steep, but you exaggerate it so you can clearly see the differences in elevation across the site. And you'll notice the lighter existing slope shown in those sections and the much heavier, darker proposed slope. And what you're really trying to do in a building like this is provide large flat areas for buildings and for parking. The maximum slope that is allowed, or that people will walk up in a parking lot, is a 3% slope. That is, the slope is, the ground goes up 3 feet in 100 feet, which we think of as being quite shallow. But if you're driving on an interstate, and you'll sometimes come to these signs that say, caution, steep slope ahead, those are like 5 or 6% slopes. So something that really feels quite steep to us as we move along the road or across the parking lot is actually, when you really look at it in section, we think it was flat, but it turns out to be quite experientially steep. So slopes we think about a lot, okay? Slopes dirt can slide, there can be runoff as water goes across them and it starts eroding the slope. So there's a lot of different strategies for dealing with it. Planting stabilizes it, both sort of ground cover planting, but larger plants that have big root structures, and that does a lot to stabilize a slope. Mulch, I've never seen that it works that much. I guess it's better than just having the dirt run off, but it seems a lot of the time the mulch runs off too. Rubble or riprap, sort of covering a slope with other things like rock to keep it from washing away. And then number four is just a retaining wall. You might, if the slope is too steep, and your geotech engineer will tell you what slopes they think have to be stabilized. You can stabilize it and leave it as is, or you might build a wall and fill. Swales are what normal people call ditches. And here's looking along a street where you can see this, there's no subsurface pipe system, stormwater system here. There's actually a series of swales on the side of the road, which is they channelize the water flow there. It runs off the road and into the ditches and then is carried down and collected centrally. Swales, you will often use swales around a building. For example, if you think about the water coming down the hillside above your building, it's going to run right into your building and flood it and cause lots of problems when it hits the central wall of your building. So up the slope, you will sometimes you'll start sloping the land away from your building. So you channelize that water and move it into swales or something so it goes past your building and doesn't cause problems. So these are the basic strategies for building on a slope. So you can create the first is assuming that you want to have a flat building platform. So you can do a cut and fill at that point to create that, like a yard around a building. You can use retaining walls to create that platform. Sometimes you want to minimize the amount of earthworks, so you can do something like a split level, which will be a combination of cutting and filling and using some retaining walls. And actually, in the two-story house, using the house itself as a retaining wall. And that's a very common practice to just say this, foundation wall works as a retaining wall, but is also a wall of the house. When we do things like cut paths or roads across a site on an angle, you don't want to walk on a path that's sloping pretty steeply. So here you can see how you can cut a path or you can fill a path so that the path goes down the slope, but it feels from right to left, it feels relatively flat as you cross it. And you can see what the contour lines do at that point. The new proposed contour lines go across the path perpendicular to the path itself. So that means it's going to feel reasonable for walking or driving on at that point. So sites, this is the earlier site, and this is kind of after it was cleared. It had an amazing number of downed trees and junk and all sorts of stuff. No one had built on it in 150 years. And so the site was pretty much cleared, and this was after, but we saved all the big trees, 10 trees on the property. And this is as the concrete pad for the house is being poured, and the regrading has happened. The dirt has been moved around, moved on the site and regraded to work with the design. So I'm going to go back to talking about how do you get contours? How do you take a plan like this, and how do you start to figure out what the contour map is if the surveyor hasn't given it to you? And essentially, you've got, here's all the sort of the spot grades we'll be working with, and how do you use the data at that point to draw the contour lines? We're going to zoom in on this section of the site so we can look at it a little more closely. And you can see that these are the spot grades. And the two we're going to look at, one says 92.6 and the other says 90.4. So between those two, there will be a 92-foot contour and there will be a 91-foot contour. And we have to find the 2 points where they'll cross. So first of all, you look at the distance between those two spot grades, and that turns out to be 11 feet horizontal distance. And then 92.6 minus 90.4 is 2.2 feet in elevation change. So when you sort of calculate the slope there, you look at it comes out to a 0.2. And we express slope usually in a ratio. No one ever talks about degrees, okay? No one ever measures an angle of a slope. It's just, don't do it. Slope is usually expressed as a ratio. So this is a 1 in 5 slope. It slopes 1 foot vertically for every 5 feet in plan, or very commonly 20%. So 100% slope is essentially a 1 in 1 or a 12 in 12 slope. So for every foot of horizontal distance, it goes up a foot in vertical distance, and that's 100% slope. So we've calculated that, and then how do we use that to sort of try to ascertain where those contour lines are? We want to locate those two contour lines. So first we set up just a little equation. We come up with the top of the fraction is the change. We want to go from 92.6 and figure out where the 92.0 contour is. So the difference between those is 0.6 feet. And we want a ratio between that, and we want to know what percentage that is of the overall change in height, which is 2.2 feet. So 0.6 over 2.2 is going to be proportional to the horizontal distance. We're going to assume it's a uniform slope, so we're assuming a linear proportionality there. So what we're trying to find is, we know the horizontal distance is 11, and we're trying to find x being the distance from the 92.6 spot grade to where the 92-foot contour is. So 0.6 times, we do a little algebraic manipulation there, which I'm sure you're all familiar with, and we come up with x equals 3. So we map that, we map out a 3-foot distance there from the 92.6, and there's the new spot grade for, that's where the 90.0 spot grade would be, and that would imply a contour line at 90 going right through there, and then you would do the same thing, or 91, I'm sorry, it's a 91. Have to fix that slide in the next go through on this. Anyway, so this is a process, then you follow that through, and here's the work I did to sort of take all of those contour lines and plot them on the site. And you notice that they're, when you see existing contour lines, they're generally curved, and that's when you're using something like cameras to shoot them, and it's an accurate measurement. For our purposes, we just want to be reasonably close, and it's obviously easier to just draw some straight lines connecting spot grades at this point. And sort of over on the right side, you can see from the 87.0 to the 82.9 spot grade, I've laid out a uniform slope there with a series of points that are like, inflection lines on that slope. So this is the finished plotting of this is the existing topography on the site. Doing that across the street and onto the neighbor's property, I took all the spot grades I could and did exactly that process to kind of lay out this existing contour lines. And then on the final site plan, those existing contour lines are shown lightly, and the darker contour lines are shown for the proposed contours as we're grading around the house. You can see it slopes away from the house, and that's not exactly what the builder did. The guy doing the site work decided he wanted to have more of a flat area right outside the house, so he kind of pushed those contour lines out. So it was a good lesson in terms of, you think you know what you want to do and you give instructions, and then the guy with the bulldozer has his own ideas because he pushes dirt around, and he made those decisions, and it was fine. In the front of the house, you'll notice the way the contour lines angle kind of away from the house, and what that's trying to do is essentially create a little swale at the front of the house. So I want a place, if the slab elevation is at 111, but actually there's a little retaining wall there because it's below grade, and you'll see that the 113 and the 112 contour lines die into that retaining wall, foundation wall, and there's a lower point on that side of the house to sort of try to direct the water around the house rather than running into it. Other thing to pay attention to is site utilities. Try to keep track of where things are. Here's the water meters for 2 adjoining properties. It's a really good thing to map where underground sewers and be very clear. Any kind of piping, any kind of electrical conduit, you know where it is. When we went to build on this site, we discovered the town had no idea where the sewer line was that served the nearby houses. They really had not kept track of this. And the house on the right here, built by our neighbors before us, they were kind of pulling their hair out about trying to discover where they should put their sewage, and we finally had to hire someone to go into an existing house and run a sensor down their drain line, down the sewer line out of their house to locate where the main was, and it turned out to be running through the backyards of all the houses there, not with any explicit easement or anything, and the town had no idea it was there. So you think people are going to give you useful information, and you'll sometimes be shocked at how little of that does exist. Okay, now we're just back to thinking about a large site plan, and briefly want to talk about parking, since parking is what drives everything in a lot of the current developments we do. And you can see the huge area of parking surrounding this building. And the usual ratio for something like retail will be about 3 parking spaces for every 1,000 square feet of retail area. And you'll go out to areas and see these parking lots are empty all the time. Well, the way we size things in our country is the parking lot is sized for the Saturday before Christmas for retail. So you want a parking lot that is so big it will never completely fill up, or fill up one day a year and sit empty with water running off it for the rest of the year. It's a pretty insane way of designing your built environment, but that's the system we've had in place, for the past 70 years or so. Parking is, this is more normally what it looks like, right? There's vast amounts of empty pavement where they sometimes have strange car races and such, I've noticed when I bike by. It's expensive to build huge parking lots, right? It's expensive, paved area costs a lot. We have less planting, it's obviously not a good thing. One of the biggest problems is the runoff. Not only is all those are all impermeable surfaces with the water running off and having to go somewhere rather than the water soaking into the ground, it's also picking up everything that comes out of the cars. So it picks up oil, and it picks up gas, and it picks up, we've come to understand the importance of copper shavings. All brake drums have copper involved in them, and every time you apply the brakes in a car, a little bit of copper gets ground off and falls on the ground and gets washed into the water system, which is turning out to be one of the major problems in areas like Puget Sound, with impacts upon wildlife and orcas and salmon runs. Is the amount of copper in the water is causing problems, and almost all of it is coming from brake linings of cars. So from our perspective, it would be nice to minimize this amount of parking, but again, it's going to be set in codes, and you're going to have a hard time arguing with it. So it's kind of up to us to start trying to change these things. So how big is a parking lot, and car accommodation? Well, cars, the general assumption is a lane that a car drives in has to be 12 feet wide. You'll probably notice from driving, most people find it really hard to drive in a straight line and are constantly weaving back and forth in their lane. The slope on something you're driving, you've got about a 10% maximum slope on driveways. Highways, 6%, as I mentioned, is considered quite steep. The parking, spaces themselves, they're usually about 8 feet by 18 feet, and the space between them when you're doing perpendicular parking is usually has to be about 22 feet. So I always just sort of say when I'm laying out a parking lot that if you're doing a double-loaded circulation in a parking lot from a car stall, the aisle between them, and then the next car stall, that's about a 60-foot width you have to allow for there. Parking lots don't have to be like this. They can be like this. This is one of my favorite parking lots in a housing project in Denmark. And you'll see that it's, where the cars go, which doesn't get a lot of traffic, it's gravel. And there's a little bit of paved area for the parking aisle between them, but you're parking kind of in a forest, and the water can infiltrate through the gravel. It's kind of a remarkably pleasant little parking lot to look at there. So now I want to switch to talking about vegetation and how that we should think about that. This is not something we learn about a lot in architecture school. This may be the only time you ever hear it come up in a lecture, but it has a huge impact. This is the Dallas Museum of Art, which I thought was a good building with a wonderful art collection, and what was most amazing was the landscape. There was a sculpture garden that was designed by the great modernist landscape architect Dan Kiley, and it was just a wonder. We walked through that, and it was, just the quality of the design he was able to achieve with these plantings, with simple insertions like walls into the landscape with axes. It was so much more important to us than what was going on in the building. It was truly remarkable. It has a huge impact on how we experience a place. So this is the same Galjebakken. This is the same housing project I showed the parking lot from. And this is what the architecture looked like. This is a suburban multifamily project outside of Copenhagen. And this is what the builders built. This is the boxes, the concrete boxes people live in. And then they built a little bit of infrastructure, a little bit of wooden infrastructure out in this shared courtyard and decided to let people do what they wanted to with this space. And this is what it looked like 30 years later. The architecture goes away. You can see that there's some concrete boxes back there, and they're just not prominent or important. That this is where humans are living, and it's not only important that it's vegetated, it's important that they got to decide what they wanted to do. So each of these courtyards was shared by 4 to 6 households, and they all worked together to decide how they wanted to develop. And each of these courtyards in the project is quite different based upon the wishes of the people who left there. So I just find this is an important understanding of how you can make a wonderful environment just by knowing how to garden and do that. Versus, this is the kind of typical environment that we'll produce in a development that will get plugged in, before the residents move in. Fence off your yard, leave some grass, plant a couple of desultory trees, and even the dog doesn't look happy out there. We can do so much better than that. It's so minimal. It really doesn't do anything to accommodate people, whereas it can have an important effect. This is my favorite plaza in Copenhagen called Grabbrødretorv, and what makes this whole plaza is this one tree. It just fills the space, and that's something to be aware of, that trees aren't things in space, they shape the space. So here you have a space that's primarily shaped by the ground plane and by the buildings all around it, but then the tree is really kind of this big solid filling up that space and completely changes your perception of it. The vegetation's dynamic, right? I see this in the summer. Obviously the space is going to look very different in the winter. There's a seasonal rhythm, it's going to grow. So when that was planted, that was quite a small tree. We try, as architects, we always try to take photos of our buildings when they're brand new and look really shiny and great before they get dirty. Landscape architects are the opposite. They really want the site photo about 30 years after the building is built. Trees, we don't know a lot about them. A few simple things. There's the trunk, the roots go down, and a very important thing to be aware of is that the roots will usually go out as far out as what's called the drip line. So you've got the canopy of the tree, and the water comes down on the edge, and that is how far the roots will go out. So don't kid yourself that you're going to be able to build right under a tree, up to a tree trunk, and have that tree survive. You'll see the fencing around that tree trunk. That's the tree protection, so that even while they're working on the site, they don't want anyone driving heavy equipment across those roots. If you compact the soil on roots with like bulldozers and such, that itself will probably kill the tree. It'll take longer to do, but it will eventually happen. And trees are just this important determinant of what a space feels like. Here in Oak Bluffs in Massachusetts, you can just sort of see there's these beautiful little houses along the street, but the character of that space completely is determined by the trees. So think of these as outdoor rooms. Trees don't fill space, they define space. So here's this pathway for humans that is really based upon and shaped by those trees. Think about it comparatively with inside a building. You wouldn't kind of randomly scatter partitions around in a building plan. Think about how those partitions shape the space, so think about how the trees shape the space also. Sometimes trees are also important as sort of a highlight. This is these trees at the end of the Ile de Cité in Paris with the non-existent spire seen in the distance there. And I always just love this spot, that you're in the middle of this very built-up environment, and a lot of hard surfaces, a lot of stone, and then there's this one beautiful little park at the end of the island that's not just a beautiful place to go to and sit in, but just seeing it there, just seeing this cluster of trees completely changes your experience of that place. People historically have used trees. We've used them in different kinds of landscapes. As I've said, we take some landscape courses if you can and really kind of learn about this. Here at the Bobley Gardens, this is the axis is created. There's not much built here, right? It's all being done with the vegetation and making a pathway there. It doesn't have to be a linear, symmetrical, formal garden in that way. There's lots of rules and knowledge of how to create landscapes, how you can frame a view in a more of a romantic era landscape like this. And oftentimes we think we're really emphasizing the architecture with other buildings. So this is Grundtvigskirke in Copenhagen, a development with a church in the middle and then housing, mixed-use development all around it, a fantastic little assemblage there. And so this axis is determined by these buildings leading you on axis to the front of the church. But then it becomes, as you back up, you realize that axis extends into a park across from it, and the trees shape it even more and as you get even further away. So the ability to use the landscape in concert with the built environment to create these very powerful movements. One of the more noted axes in the world, the axis out the rear of the palace at Versailles, where you're looking down this axis and you see these canals in the distance, and it extends really out there for miles, and how the trees frame that. And to me, what's always seemed most important are these two poplars at the end. That it isn't just a mass of trees on either side, that the mass sort of ends, and then these two poplars sort of stand there and give you scale at that point, and then really clearly delineate that axis moving out there. There's a lot of places where this is done, where this is noted. We'll talk about Savannah later in the term, and we'll talk about how wonderful the city plan is and how the spaces and the streets are formed and the hierarchy there. But the experiential quality of Savannah, a lot of it is formed both by having these series of parks in the middle of these different wards of the city, each of which is, landscaped and designed differently, and also the quality of the streets, where these giant live oak trees that hang over the streets, just this canopy. Just try to imagine how different the scene would be if it were if those trees were not there. Sometimes we think about what trees can do for us, and we should be really clear about what they can do and what they can't do. They work quite well in terms of energy performance. You can see there's a building with some extensive shading devices on the building, but then also trees planted on the outside of it to sort of help shade them, from the summer sun, or just all the sun there in Arizona. They're really good for privacy. You can use vegetation for blocking views, for screening buildings, for screening views you don't want to see. They're pretty effective as windbreaks. If you obviously are out on the prairie, you can see places where people have planted rows of trees as a way of stopping the wind howling across the open landscape. They're good for erosion control, as I mentioned before. The one thing that trees are not really good for is acoustics, okay? People think that they're going to plant some dense tree barrier or bushes or something and stop a lot of noise from a highway. It just doesn't work. Noise will go right between them. Noise will go through, a 1-inch opening in something. So if you want to stop noise, you need something solid like a wall. Don't count on trees to do that. They'll do it visually. There happened to be an article in the New York Times this morning by Oliver Sacks, the noted late neurologist, and it's from an excerpt from one of his books on the healing power of gardens, and says that in all of his experience as a neurologist, the two things that he found would worked better than therapy or worked better than drugs and really got through to people with serious problems were going out in nature and music. And so it's the whole article, which you should take a look at, is really about the importance of integrating this into our environments, and particularly urban environments. I think this is something we all know here in Oregon, but I think it's something that we can often lose sight of when we're working in other places. My prime example is Central Park. Central Park, as I mentioned, was a built, designed landscape. This is not all natural. This is the northern end of the park, which feels like it's more natural, but this too was shaped by Olmsted. And it's hard to imagine New York City without Central Park. If you can think of, if that were all just the street grid and that there were buildings filling it up, the city would be a really different place. And so a lot of the time, I think we don't learn enough about how to design landscapes in architecture school. So as like I said, take some landscape course if you can, or just go befriend some landscape students down the hall when you're working on a project and buy them a beer and ask them to come critique your project and see what might improve it from their perspective.